Similar triangles have side lengths that are proportional. That means if I take any side from triangle number 1 and I multiply it by the scale factor, I will get the corresponding length of triangle number 2. So in this case, the scale factor is 2. Scale factor is 2. That's a C. Scale factor is 2 because 2 times 3 is 6, and 2 times 4 is 8, and 2 times 5 is 10. So the scale factor is the number that we multiply each side of triangle 1 to get triangle 2. So those two triangles are similar. Another property of similar triangles is that the angles are not proportional. They're actually congruent. That means that angle X in triangle number 1 has the same measure as angle X in triangle number 2. So there's actually something else cool about similar triangles that gives us information about trig functions, well, trig ratios. So let's look at the ratio of sides of triangle number 1. Let's say we look at the ratio of the side opposite to X over the side that is adjacent to X. So this is triangle number 1. So the side opposite of X is 4. The side adjacent to X is 3. So the ratio of the side opposite to the side adjacent to X is 4/3. Let's do that with triangle number 2. The side opposite to X is 8. The side adjacent to X is 6. Now we can divide that top and bottom by 2. And 8 divided by 2 is 4. 6 divided by 2 is 3. Well, if you look here, 4/3, 4/3. The ratios of the sides are equal. Let's look at the side opposite to X over the hypotenuse for triangle number 1. So for triangle number 1, opposite is 4 and hypotenuse is 5. So that would be 4 over 5. And then for triangle number 2, opposite is 8, hypotenuse is 10. So that would be 8 over 10. And again, we can divide this top and bottom by 2, and we get 4 over 5. And again, we have 4/5 here, and we have 4/5 here. Those are the same. So the ratios of the sides, opposite over hypotenuse, are the same for those two different triangles. Lastly, let's do adjacent over hypotenuse. Adjacent just means next to. So for triangle number 1, we kind of have two sides that are next to it, but one is the hypotenuse. The hypotenuse is the side that's opposite of the right angle, so the adjacent side is the other one that's next to X. So that's 3. So adjacent over hypotenuse would be 3 over 5. So 3 over 5. For triangle number 2, adjacent is 6, hypotenuse is 10, so that would be 6 over 10. 6 over 10. So we can divide that by 2, and we get 3 over 5. And look here again. Those ratios are the same. So for similar triangles, not only are the sides proportional and the angles are congruent, but the ratios of two different sides are equal. Well, that's great because we say that the definition of some very important functions come from this. So trig functions can be defined by looking at triangles, right triangles. If we want to say, what is the opposite over adjacent? Let's see, that is tangent. The tangent of x is opposite over adjacent side in a right triangle. So tangent of x equals opposite over adjacent. And tangent of x is the same for both triangles. That's really good because x, the angle, is the same for both triangles. So that's telling us that tangent of x is going to come out the same for both of those triangles, which is how it should be because x is the same. And that's going to work out as well for sine of x, which is opposite over hypotenuse. So sine of x, opposite over hypotenuse, comes out the same as well. And so does cosine of x. So what we're seeing here is that the trig functions come out the same for for an angle x if the triangles are similar. So, big picture. The trig ratios of a given angle, in this case x, you could say x is 30. The trig ratios of an angle are always the same. That means sine of 30 is 1/2. Always. Always, always, always. If we have a triangle and one angle was 30, and we take the sine of that angle, it's going to come out to be 1/2. So like up here, we said tangent of this angle x is 4/3. And that is the same for both triangles. Tangent of x is 4/3. X is approximately 53 degrees. So what we're saying is the tangent of 53 degrees is the same, which is great. That's where the trig ratios come from. They come from similar triangles. The ratios of sides of similar triangles are equal, and that's why we can define the trig functions by using those side ratios of opposite over adjacent and opposite over hypotenuse, etc.